Hi, Professor Chon and anyone who is watching. This is the demonstration of the part 1 of the laboratory 1 of EE542. I am doing this because the video is preferably recorded by phone according to the laboratory instruction. Now you can see there's a white box on my desk, and believe me, this is not an advertisement. This is the temporary stand that I made for my phone to record the monitor. So right now I will attach my phone onto the stand and the demonstration begins. So the first part is about the Linux operating system. Basically, we need to install the Linux operating system as a virtual machine onto our computer. So in order to do that, we need to install the virtual machine environment, which is the VirtualBox software first. Then we can install the Linux operating system into the VirtualBox as the virtual machine. Also, if we just follow the laboratory instruction, we will encounter two problems, as I listed here. So now I will begin to install the VirtualBox and the virtual machine, and also show you how did I manage to solve these two problems. So the first thing we need to do is to download the VirtualBox software. To do that, we just open a browser, then Google VirtualBox, and click into the official site, click download, and select the right operating system. Mine is Windows, and wait for the file to be downloaded, and open the file and just click next, and I have already installed. And so there are no fancy things here. Just follow the procedure, then all will be fine. Now we have installed the VirtualBox. The next thing we need to do is to install the Linux operating system. To do that, we need to first download the operating system mirror. And the laboratory instruction here gives a link, but in this link, it is using the Ubuntu 17.10, but this version has reached its end of life. So we need to change a version. The version that I use is Ubuntu 18.04. Just Google that and go to its official website, and here search for the right mirror, and we need to download the desktop version, not the server version. Just click this file, then the download will be started. Now that we have installed the VirtualBox, we can start to install the Linux operating system. Before that, we need to make sure we can fulfill the minimum requirement of the Linux operating system. To do that, we just search the minimum requirement of the Ubuntu 18.04, and now here we can see the minimum requirement. So we can begin to create the virtual machine. Here we just click new and input the name of the virtual machine, and also configure the path for the virtual machine file. Also select the right type and the right version. Click next, and here as the laboratory instruction mentioned, we will set to 512 megabyte memory, and also just follow the procedure to create the hard disk. And here we need at least 25 gigabyte of disk. So 25 and create. So now you can see here our new virtual machine has been added. Once we created the virtual machine, we can start it now by click the start button here. Now it will pop up a window to let us choose the ISO file, which is the mirror file. So here we just add our mirror file that we downloaded to here, and select it, choose it, and we click start. And wait for it to boot up. Okay, here comes the problem. It said panic, not syncing, attempted to kill the idle task. So this is the problem that I mentioned before. This is the problem 1 actually. Yeah, the reason for this is that the virtual machine only has one processor, and the minimum system requirement is at least 2 core of processor. So how to solve this is just to change it to the minimum system requirement, which is 2 processors. Also, we will encounter the problem 2, but it is time consuming. So as you can see here, we set the memory to 512 megabytes, but its minimum requirement is 2 gigabyte RAM. So if we proceed with this RAM, we will encounter this problem. So we need to change it to the 2 gigabyte RAM. So to solve this 2 problem, we close this virtual machine and right click the virtual machine, go to the setting, and in here in the system processor, we add 1 processor, at least 1. And yeah, my computer is a little advanced, so I will give it 2 to 4. And also the motherboard base memory, we change it to 2 gigabyte, which is this, and click OK. Now if we started this virtual machine again, it will not have any problem. So we click start and wait for it to boot up. Great. Now begin the installation process. So in here, we need to install Ubuntu. And in here, this is the keyboard layout, English, US, no problem. Continue. Normal installation and download while installation while. Okay. Continue. erase disk and install Ubuntu. Yes, so install now and continue. This is just a very normal configuration. And here, where are you? Yeah, Los Angeles, continue. And now we enter the name. My name is Donghao Zhao. And give a password. And we just give the password. So continue. Now we just wait for the installation process to complete. Yeah, after waiting for a long time, the installation process now is complete, and we need to restart now. Just click this button. And yeah, in this state, we just close the power off the machine and start it again here. And wait for it to be booted up. All right, and we enter our password here. And okay, these are not important. Okay, now we have successfully installed the Ubuntu Linux operating system, and it is working. And this concluded the part 1, which is the Linux operating system, and the installation process has been recorded. And all right, this is the first part. Now we begin the second part, which is the computer network. So the computer network, the first few steps are relatively straightforward, and we need to install the network related package. To do that, we just copy this command into the terminal and run. Then the package will be installed. And the second thing is to install the virtual machine guest edition. To do that, so we can click the devices here and click insert guest edition CD image. Then the ISO will be mounted up, and we just click this run, and then all will be good. So the third part, to create the root account and set the password. Also just copy this command to the terminal, and also it's straightforward. And to start the SSH service, it's the same to run these two commands. Then we can clone the virtual machine and group them. To do that, we need to power off this virtual machine, and then right-click the virtual machine and click clone. Here we need to give the new virtual machine the name and also the path, and then we need to select the linked clone, and we tap clone, then all will be done. And how to group them is we can press Control or Shift to select a bunch of them, and we click group. Then then the virtual machine will be grouped. After that, we need to configure the network configuration between the virtual machines. So we need one of the basic computer topology, which is two PC connected by a router. So in order to do this, we need to configure their VirtualBox interface. So to do that, we right-click the virtual machine and click Settings. And in here we can find the network here, and it has 4 adapters. So we just because this is PC1, and we just need 1 adapter here, and we will give its name, which is the Internet 1, and click OK. So the PC2 is the same step, but it will connect it to Internet 2 because PC1 and PC2 are connected to different network. And the router 1 will be the bridge between 2 networks. So it will need 2 adapters. Adapter 2 connected to Internet 1 and adapter 3 connected to Internet 2. And the connections are listed here. One thing I need to mention is that the network type are all internal network, so we need to select internal network here. We should also configure the port forwarding on NAT interfaces. This will allow us to map the port number on the virtual machine to the port number on the host machine. To do that, we need to go to the network setting of the virtual machine, and this time we will select the adapter 1 because it is attached to the net, and go to the advanced setting and select the port forwarding. Here the 22 port number is the port that the SSH service is using. So here we map the 22 port in the guest machine, which is the virtual machine, to the host machine. The port I selected is 14.3.6.01, and we do this to all the virtual machines. You can see here it is the same port in the guest machine, but different port in the host machine. Once we configure the port forwarding, we can connect to the virtual machine through the terminal on the host machine. But to do that, we need to start the virtual machine. To start a group of virtual machines, just click the group and select all the group, and then click Start. It will take some time to start all 3 machines. Now the virtual machines are all started, so we can open a terminal on the host machine and use this command to log into the virtual machine. So this command is so we use SSH service, and the login name is Donghao, which is my name, and the port number is 14.501. And so this will be the PC1, and the localhost is the IP address, which is the host IP address, which is the host itself. So we just click Enter, and we tap the password. Then bingo, we are in. And by doing the same command in different terminal, we can log into the to all three virtual machines. Here comes a very important step, which is to configure and test network nodes. So to do that, we just need to run these three scripts in their corresponding virtual machines. So I'll give an example, which is here in this path, which is the home path. We can see a script named the net configure PC2 script sh, and we will see the content, and you will see they are the same, and it is also the same in the other virtual machines. Okay. So this is the script for the router, and this is the script for the PC1. All right. So in order to do that, so how could we run this machine? How could we run this script? So we need to first give the file the permission to run, which is chmod 777 and this file. So this will grant the script the permission to run. Then we just run this script. It's relatively easy. So we will do the same step for all three virtual machines. And after running the script, we need to restart all three virtual machines. And after restarting, the network will be established. So what's the function of the script? So basically the script is configuring a network like this. So in this network, we have three nodes, the PC1, PC2, and router 1. And PC1 and PC2 are connected to different networks. They are all connected through a router. So what we want to do is to establish the connection between PC1 and PC2 through the router 1. And what we already configured is, so we have configured the PC1 to use the S8 as its network interface. So this EMP0S8 is equal to the network interfaces that we set before. So this is the adapter 2, and which is the internal network, which is this, and it is the same for the PC2, and which is it is also using the EMP0S8. And for the router, we have configured two network interfaces, which are adapter 2 and adapter 3, which is S8 and S9. So what we wanted is so the router 1 will use adapter 2 to connect to the PC1, and the router 1 will use the adapter 3 to connect to PC2. And so the router here will provide the router will have two NIC cards. One is the NIC card for Internet 1, and the gateway net gateway address is this IP address, and the PC1 will have this IP address. They are in the same network, and in Internet 2, this is the IP address of the gateway, which is the router, and this is the IP address of the PC2. So they are in the same network, and so the configuration are listed here. Now we take a look at the code to configure the network of PC1. So here it is it is a bash script, and it is telling the network operating system that the PC1 is one of the host name and one of the hosts, and it is configured the computer itself as the host name is the PC1, and then it is going to insert these information into this file, which is the network interfaces file. And in this file, it is telling the operating system that so this network interface is we will configure it as it is using the static IP address, and this is the IP address, and this is the subnet mask, and we will also configure an uplink route. So we will add the network. This is the network, and we will add the gateway IP address, which is the IP address of the router of this network interfaces. So after doing this, we will restart the networking service, and the code for PCR is basically the same. The difference is that it has different IP address, and it also has different gateway IP address. So these are the same. The code to configure the network for router 1 is a little complex. So here it is saying that this is also a bash code, the bash script, and it is telling it is saying that the router 1 is one of the host name, and the router 1 is also one of the hosts, and its IP address is this, and it is configuring itself as router 1. So now it is installing something. So it is basically it first update its package, and then it will install the Quagga and the Quagga dog and the trace route. So after installing this package, it will copy the sample configuration of Zebra and OSPFD to the real configuration file, and also give it some permission. So actually, these are codes to just configure the Quagga. And after doing this, it will insert these information to the OSPDFD configuration file. So so this code is basically telling that we have 3 interfaces, actually 4 interfaces, and we will use the OSPF router, and the OSPF router will configure S8 and S9 as passive interface. So this is corresponding to here. We have S8 and S9, so we need 2 passive interfaces, and we have 3 network here, the 3 network, and also we will insert these information to the Zebra, and these information basically is telling the operating system that so for this network interfaces, we will configure the gateway IP at this, and for this interfaces, the gateway IP is this, and for this interface, the gateway IP is this. This is basically like So so the so for this for S8 interfaces, so this is the gateway IP address, and for S9 this is the gateway IP address. Yeah, and then it will restart the Zebra and OSPF services. Another trivial thing is that if we configure the network like this, that we will not be able to ping the google.com. So to fix that, we need to go to the installation directory of the VirtualBox. So to do that, it's like we will navigate to the installation path step by step, open file location. So this is the installation path of the VirtualBox, and in here we open a terminal, and under this path we will run these commands to configure the some configuration for PC1 and PC2 and router 1. So after running this configuration, then as you can see here, we will be able to ping google.com. So here is the proof of the network configuration. So this is the PC1 and this is the route command. After running this command, we can see that in here the PC1 is connected to this network, and the network gateway. This is its IP address, and also this is the same for the PC2 here, and also for the router, it has connected to two different networks. So this is the first one, this is the second one, and it is the same as this network topology. And also we can see here we want to know the trace route from PC1 to PC2. So it will first go to the network gateway, then it will go to the network. Go to PC2, and it is the same to the PC2. The following steps will be about VYOS and DHCP. So we need to let PC1 and PC2 be ready for that. And to do that, so we will configure the network interfaces file and delete those static IP address configuration and replace that with DHCP. And so the same will be implemented on PC1. And after that, we will need to restart the virtual machine and start doing something with DHCP and VYOS. So we will begin to install the VYOS to replace Quagga. And the procedure is very much the same because the VYOS is another operating system. So we just follow the same step that we did to install the virtual machine in the VirtualBox. So the first thing we need to do is to download the VYOS OS mirror. So we just Google this and go to this website, and here is the warehouse, and just click on this, then the download will be started. And okay, so I have already downloaded this mirror, so we just follow the same step here. We created a new machine, virtual machine, and select the name and also the path. And in here we will select this is the Linux, and we will use Debian 64. So this is the right type. So click next. And in here we need to know the minimum requirement of the VyOS. So we just minimum requirement. So as you can see here, it just needs 512 megabytes, and created this disk and give it. So it needs 2 gigabytes of storage. So well, we'll be generous and give it 8, I think, and create. So now, yeah, you can see so this virtual machine has been created. So we need to start this virtual machine. If we just started, we will encounter the same problem of because we just used one processor. So we will adjust this to 2, and we start. Okay, here's the same thing. So we need to choose the system mirror, and we add this into the list and select it. Choose start, and wait for the system to boot up. So yeah, here you can see it's pretty much the same interface. So we just go to the first one, and wait for the system to boot up. Alright, it has been booted up, and so we need to log into the VyOS. So the default username and password is, the username is VyOS, the password is also VyOS. Now we have stepped into the operating system. So the next thing we need to do is to install it. So to install it, run this command: install image. Install image. So here we will begin to install this system. So just follow, just go through the steps, then the system will be installed. After we install the operating system, the VyOS, we need to restart it. But before we start the virtual machine, there are 2 things we need to do. The first thing is to eject the mirror. You will find the mirror in here. So if we didn't eject the mirror, then the virtual machine will still be booted up to the mirror, not the real operating system. So this is the first thing we need to do. And the second thing we need to do is to configure its network adapter. So we will need 2 adapters here, and here it is pretty much the same topology. The adapter 2 will be connected to the Internet 1, and the adapter 3 will be connected to Internet 2. So this is all the settings, and then we will start this virtual machine. So here you can see this is a different interface between the installation compared with the installation process. So we will wait for the system to boot up. already the system has booted up, and sometimes you need to press enter and to log in. So the virtual uh, the virtual machine and the username for VYOS is also VYOS, and the password is the password that you set during the installation process. VYOS, the password. Now you can see that we have successfully stepped into the VYOS operating system. Now we can set up interface and the DHCP server. So to do that, we need to just type this command into the operating system. Then all will be done. So how could we do that? Here is the copy of the command. So to do that, we need to type each command by our hand. So like this, and so configure and yeah, it's just type this command by hand. And so this is pretty straightforward, and I will not go through this process for the sake of the demonstration, because it is really time consuming. So what's the function of these codes? And so the first one is to show interfaces. This will show the interfaces, network interfaces that the operating has. And the second one, configure. So by typing this command, we will step into the configure mode of the operating system. This will allow us to modify something. The third one actually is not working in my operating system. Actually, my operating system doesn't need this configuration. So this is basically telling the operating system that to enable the DHCP server function. So then the fourth, so this one is just to clear console, clear some history message that we don't want to see. Then this block is the network configuration of the DH server for Internet 1, and this one is for Internet 2. So for this one, this is telling the operating system that the interface. So for this interface, we will set the IP address as this. And also, we will set the description. The description is trivial. It's just a reminder for humans to understand what we are doing. And also, here we are configuring the DHCP server. So we do this by set service and DHCP server, and we will identify the name of the shared network, which is S8, which is this one, and also identify the subnet mask. And so as you can see, these are all the same for these commands. And so the first one, we will set the default router as this IP address. So it is according to this. And also the DNS server, which is the same as the default router in this case. Also the domain name is also just a reminder. So the next thing is to set the lease time. So this is the 24 hours, which means that the DHCP server will grant its client with a new IP address after 24 hours. And then it will need to set the range of the DHCP service, the range of the IP address. And so it will start at this IP address and end at this IP address. Okay, so after we configure this, we will by type this command, we will
the operating system will show us the configuration of the DHCP server. Then for this block, it's pretty much the same, but it's just a different interface, different description, and also different default router and default server according to this, and yeah, and also different range for the IP address. Then after we have done this, we need to commit to the operating system, and also save the configuration and exit the configure mode. So after these steps, the DHCP server has been configured and is online. So we can start the PC1 and PC2, and also to look for the IP address. So this is the IP address for PC1, and this is as our desired, and this is IP address for PC2, which is also our desired. And we can also verify this in the VYOS. So by type this show interfaces command, so we can see there's a PC1 and PC2 network interface, and also if we show the DHCP server lead for in this command, then we can see the DHCP server distribute two IP address, which is the same as the IP address of PC1 and the IP address of PC2. So also we can show the DHCP service. So by doing this, the configuration of the DHCP service, so we need to enter into the configure mode and type show DH service DHCP server. So this will show the DHCP service that we have configured, and as you can see, so this is pretty much the same as I mentioned before. So this concluded the third part of replacing the Quagga with VYOS. Also, I would like to make sure that it can ping each other. So we just ping the PC2 in the PC1. As you can see, it is connected, and we also ping PC2, ping PC1 in PC2. So it is also connected. So now we conclude the third part. Now we come to the most important part of the laboratory assignment, the socket tutorial. So in order for client and server talk with each other through network, and so the server and the client need to use socket. So basically, the server needs to run first. The server needs to create a socket, then bind the socket with its IP address and port number, then listen to the IP address and port number for any incoming client communication. So after the server has booted up, the client can connect to the server. So the client will also need to create a socket and try to connect and run the connect function to connect to the server. And so once the server detects that there's an incoming call, then it will accept the connection. So after that, the bidirectional communication has been established. the client and server can use read or write function to communicate with each other. Then after they have done the communicating, they will need to destroy their socket. So the server, once he has accepted one client, it will go back and still listen for any other client with the intention to communicate with the server. So this is the client and server model for the network communication using socket. There are two domain types and two socket types. For the domain type, the first one is the Unix domain. It is used for the common file system communication, and its address is a character string. So basically, it is used for the communication within a file system. So it's like the machine communicates with the machine itself. So another domain is the internet domain that is used for internet communicate. That is, which is used for the machine to communicate with another machine and its IP address, and it is using the IP address. So and for the port number is 16-bit unsigned integer, and so the port number, so the value below the 2000 are actually preoccupied by some random service, and the value above 200 some are generally available for any other use. And there are two socket types, which is the stream socket and the datagram socket. So the stream socket is used for continuous stream of characters. It uses the TCP, which is the transmission control protocol, and it is very reliable because it is connection oriented. And the socket type, another socket type is datagram socket, which reads the entire message at once, and it is using the UDP, which is the Unix datagram protocol, but it is connectionless socket, so it is unreliable and message oriented. Now we can take a look at the sample code that provided by the laboratory assignment. So this is the server.c and the client.c. These files can be downloaded from the Blackboard. So to use this code, we just compile the code first, and then here use these two commands. Then we can run these code, and one from PC1 and one from PC2. So the PC1 will be as a server. So just type this server, and so this is the port number. So now it is listening. And for the client side, we need to use this command, which is the client, and we will need to identify the IP address of the server, which is this one, and also the same port number as the server is listening to. So after I type this command, then suppose we type some message, then here you will see that it will receive the message. The server will receive the message, and the server will send to the client to notify the client that the server has got the message. Actually, I did some modification here for some advanced technique, but basically, if we run the original code, it will be like this. So the server, after the server has received the message, it will exit, and it will terminate itself. It won't listen to any other communication from, incoming communication connection from the from any other client. So this is the behavior of the sample code. Now we will step into the code of this uh, source file. So there will be two codes here. The first one is the server.c and also the client.c. And now I have also done the enhancement to the server code. So I will combine these three codes together. So here you can see that this is the server.c, and so this file, this source code is a simple server in the internet domain using TCP, and the port number is passed as an argument. So what does that mean? So pass something as an argument is like, so in here the IP address and the port number is passed by the operating system. So here are some libraries, and so this is the standard input and output library, and some basic library here, and this contains the data types used in the system calls, and this is the system's structure needed for socket, and also some so in this library will contain some constant and structures for internet domain address. And for this one, this is a wait PID function. The wait PID function will use this library, and I will mention this later. And for this function is an error printer actually. So it will take the input, which is the char pointer as a message. This is the message, and also it will print the message to the standard error as a standard error. And here is a function to handle the zombie process, and I will mention this later. Then we come to the main function. So the first part, so in order to do this, we need to create a socket first, which means, so these are some definition of the variables. So we need a socket file descriptor, and also a new socket file descriptor when the client comes in. So and then the third one is the port number. And for this one, this is a buffer that used to receive data. Basically, when the server receives some messages, we'll put the message into this buffer, and the size it has been set. And also, this is something to manage the zombie process. I will mention this later. And also for this, so for this structure has this member variables. So for this member variable, the first one is internet type, and actually for now it is always AF internet, which means we are using the internet here. And for other network type, we will change that. But I think for this course, we will be only talking about the internet. And the second one is the port number. The third one is an unsigned long called S address. This is the IP address. Then the fourth one is not used, and it must be set to 0. And for this, this is a argument checker. It is saying that so the server, when we start the server, we need to provide with a port number, and if we provided the port number, then we will have two arguments. So the argument count will be 2, But if we forgot to provide the port number, then there will be only one argument count. So this is like saying that if we forgot to provide the port number, we need to prompt to the user that hey, you forgot to provide the port number. Okay, and there's also no need to do the following things. So we exit and let the user to provide the port number. So then here comes the part of create a socket, which is the first part. So here we create a new socket and pass some argument here. It is saying that this is an internet socket, and it is using the TCP and not UDP. And to set 0 here, it means to let the operating system to choose the most appropriate protocol, and it will return an entry into the file descriptor table, which is the socket file descriptor. So here it is saying that if the socket descriptor is less than 0, which means the socket has not been we failed to create the socket. So in this case, we will prompt this to the user about this information. Then we need to use this function, which is b0, to set all values in this buffer to 0, and so it will pass two parameters. The first is the buffer that we want to set to 0, and also the size of the buffer. Then we need to convert the port number from string to integer, and the reason why we do that is that the port number is passed as an argument, so it is char pointer type. But in order to do that, we need to use it as an integer. So we use this a2i function to convert the port number to the integer. Then we set the server address structure, which is so the internet should always be internet, and also by setting the address. The address is in here is in address any, which means the address of the machine itself, which is also the IP address of the machine on which the server is running. Then we will provide the port number, and also we need to convert the port number to host byte order, and to set it by using this function, and give the converted port number to this variable. So this will done the created part. The second part is to bind, and to use this function, we will bind the socket to an address. So we will need the socket file descriptor. This is the previous one, and we will also give it the address, and also the size of the address. And if the bind returns something less than 0, that means the binding process is failed. So we will also print this error. So after bind the socket, we will need to listen to the address and the port by calling this function. This is meaning that we will listen to the address and the port, and the backlog queue is 5, which means there are at most 5 clients can be in the waited list to wait for the server to connect it, and the maximum number is 5. So in this case, which means the 6th client will not be served when the waitlist is full. Then we come to this loop. This is the main loop, and which is correspond to the loop here. So basically, it is calling the accept. So if the client prompt up and calling the connect function, then this accept will accept this client, and so this will be a socket descriptor here, and also the pointer to the address of the client, not the server, and also the size of this structure. And also, so the calling this accept will block the client, will block the server, as I mentioned here. And also it will the accept will return a new socket file descriptor, which contains the information of the server and the client. So if the news here we are seeing that if the accept is failed, then we will print this error. And here is some multi-process technique. So we will fork this program. So the base if one process will so if this fork is failed, we will print an error because it has failed. Yeah, and if this is the child process, we will close the server socket because we won't need that, and we will initialize the buffer, then read from the socket, read a total. So by initialize, we call this function and initialize the buffer to all 0, and we will read a total on this count of characters, whichever is less. So by calling the read function here, it will read through the new socket file descriptor and put the character into the buffer, and at most 255 character. And notice that we define this n in here. And so if this n so the read function will return the numbers of the character read. So if the numbers of the character we actually read is less than 0, then we'll have some malfunction in the reading. So we will print this error. And also if the read success, then we will print whatever we read by in here. So after we have received the message, we would like to tell the client that we have got the message. So how did we do that? We did that by this function, which means that we write to the socket and tell this is the message that we would like to send to the client, and also the size of the message. And if the write didn't work well, it will also print the error. And here the socket, the child process has done its mission, so it can leave and it can retire actually. Yeah, and then so this is what the child process do. And else, this else here means that if the if the process ID is not equals to 0, which means it is not the child process, which means it is the parent process. So it will close the new socket file description, because the parents don't need this. The parent process will only need to accept new socket. So the parent process actually will just go to the beginning of the loop. So this is the loop here. And after all things are done, we can close the parent socket and return 0. So this is the details of the server code. Here comes the client code. So the code for the server and the client, so the majority of the code are the same, except for the client, we need 3 arguments to be passed to the program. So it's like in here we need to not only tell the port that the server is listening, but also we need to tell the client the server's IP address. So here we need to check if or not we have 3 arguments. And so this is the first thing. The second thing is that for the client we need a structure to hold the information about the server. And so this is the structure that holds the information about the server. And so the third thing is that in the client code, it doesn't have bind or listen or accept. So it has only one function, which is connect. And the connect function is here. So basically it is trying to connect to the server. And then it's pretty much the same as the server code. There's a very important problem for the original code provided by the laboratory instruction, which is the zombie problem. So for this problem, basically it is saying that when the child dead, then it will send a signal to its parent process, which is the signal is the signal hold for this signal, and so the parent basically it should manage to capture this signal and do something. If the parent doesn't do anything about this signal, then the life cycle of the child process has not been ended. So that's why the zombie problem emerged. So to solve that, we just programmed the system to handle the signal hold signal. So how do we do that? First, we need to register the signal hold to a signal handler. This means that whenever we receive this signal, we will do something, which is the function of this, which is this function. And within this function, it is saying that it is continuously detect whether or not we have received this signal, and if we receive this signal, we will try to manage it, which actually is doing nothing. But here it is trying to print something. So the -1 here, it is meaning that we will wait for the death of any child process, and this micro here means that if there were no child process, So this function will immediately return 0, which means no process doing nothing. So by adding this code to the server.c program, we will successfully solve this zombie problem issue. So one thing I would like to mention is here we can use this command to detect any zombie process within the operating system. And after we use this advanced server, the zombie problem has been handled. There is another kind of socket which is the datagram socket. So there's some difference between the datagram socket and the stream socket. Datagram is unreliable because it will not be acknowledged, which means we will not know whether or not the package has been dropped. The second thing is that the message boundaries are preserved in datagram socket, which that means we will need to read the message at once. The third thing is that the UDP socket uses send to and receive from rather than read and write function in the stream socket, which is there is just a different encapsulation. The first thing is that the datagram socket has a lot less overhead because it is connectionless and has no acknowledge, while the TCP, which is the stream socket, will consume a lot of resources because it is connection oriented, and it will need ACK to acknowledge to move further. Here are the code for the UDP server and the UDP client. So how to run these two codes are relatively the same at the TCP server and the TCP client. So we just compile the code and then run it. And as you can see here, we need to feed the client with the server's IP address and the port the server is listening to, and also, but for the server, we just need to provide with the port number because its IP address is the IP address of the server itself. So for the code, actually, the code is relatively simple than the TCP server and the TCP client. One thing, there's something different here, which is the first thing is here. We need to use datagram rather than stream socket. We need to change this. Also, there are no accept function here. So in UDP we don't have accept, but we still need, and also we don't have the listening function. So it's just we just call this function which is received from, and it will listen to any for any incoming passage, and also to try to distribute it to the desired port number. So for the client side, it's relatively the same, but they actually, so the UDP is not connection oriented, so it doesn't have connect function here. So it is actually using the send to function to send all the packets. It is still use the receive from function to receive all the messages. Another type of domain is the Unix domain, and I downloaded the file from the instruction of the laboratory and compiled and run it. So here, as we can see, the way so the parameter that we provided to the server is not an IP address. It is some the server socket. Actually, this is a file. Actually, this is the path of the file. And after running this, it's actually a new file has been added to the path. But so this actually is some kind of pipe. So the server actually created this pipe, and it is pouring something into the pipe, and the client will also be connected to the same pipe. So the server pours the message to the pipe, and the client retrieve the message from the pipe. So this is what the Unix domain sockets do. So the last thing is about designing servers. So this is like some philosophy for designing a server. And there are two types. The first type is concurrent connection-oriented servers, and the second type is iterative connectionless servers. So the first one, in the first one, its feature is to create a stream socket and focus off. The stream socket is actually that is using the TCP protocol. It is connection oriented, and the focus. And why we focus it is just because it will improve the performance. And some example of this type of server is the telnet server and the FTP server. So for the disadvantage is that for this connection-oriented servers, it will have high overhead for forking, and also have high overhead for the kernel side. But why we have this disadvantage, it is because the server socket is using TCP, which is high overhead in establishing the connection and also transmitting the information. But the advantage is that the data transmission is reliable in both directions, bidirectional. So that some application scenario, when do we need this connection-oriented servers? So that is when we need the capability of handling several clients simultaneously, but each connection is I/O dominated, and the select system call can let servers replies quickly and then listens for the next one. So actually, this select is another function that can provide this kind of feature. So for this connectionless servers, no forking, and it is using the datagram socket and also the UDP protocol. And some example is the finger daemon and the time of day server and echo server. So the disadvantage is that the connection is actually unreliable, and because there are no built-in mechanism to detect and handle the loss of the package. But the advantage is that it has much less overhead. But why we have this disadvantage is that the server handles each message as it receives them in the same process. So now the whole laboratory is concluded. Thank you for your watching.